Hello Year 8s. Today we're going to be talking about rational
and irrational
numbers. So, rational numbers, they just make sense. They're clean, they're tidy, we use them all the time.
Yeah, they're a bit boring. It's kind of any number that you already know about, okay? But there's this really special group of numbers called irrational numbers. Creative, unpredictable, unbelievable numbers.
You're unbelievable.
So what kind of numbers make up rational numbers then?
Whole numbers, fractions, recurring decimals, and terminating decimals.
You use some big words there, so have you got some examples that might help us understand some of those?
Yeah, let's take a look.
All right.
Okay, so rational numbers, Mr. Wilkie. We've got whole numbers. 3, 57, -8.
So any integer?
Any integer, right.
Fantastic.
And then anything that can be represented as a fraction. So 1/2, 1 on 2, 1 on 10, 34 on 93. All rational, they all make sense.
So any fraction,
Any
part of your group, rational numbers.
That's mine, yep.
All right, keep going. I'm getting bored, but keep going.
My group, rational numbers, also gets the terminating and recurring decimals. Terminating decimals are decimals that stop. They have a finish. So 0.1, 0.5, 1.64. They don't just go on, they finish.
Gotcha.
Recurring decimals, they keep going, but they have a pattern. So they recur, the pattern repeats. 0.3, where that little dot at the top means that that 3 is repeating indefinitely. 0.54 and 1.326, where the line or dash across the top of those numbers means that whole set of numbers is recurring.
So this one goes 0.54, 54, 54, 54, 54, forever?
Forever.
And this one goes 326, 326, 326 forever.
That's right.
So almost interesting, but stays boring because it's rational.
Just makes sense, so.
Or, coming over here, we've got some pretty special numbers here. We've got these irrational numbers. Now, irrational numbers, they are decimals that go forever. That's it. Stop thinking, they just go forever. So here's the first example. 7.739246850021, and it just keeps going forever and ever. You will notice there's no boring patterns like over in rational. This is creative. It goes on forever and you cannot predict it.
Sounds useful.
It's incredibly useful. I think he's being a little bit smart there. But let's have a look at the most useful irrational number there is. Check out pi. Now, you know I like pi.
Yeah.
Pi is actually when you take the outside of a circle all the way around like the circumference and you divide it by the line that goes from the top to the bottom straight through the centre, also known as diameter. If you do that circumference divided by the diameter, you get this magical number pi. Now that works for any circle, but check out pi. 3.141592654 ... because it keeps going forever.
Wow.
Incredible number, incredible. Irrational numbers don't stop there. We've also got any square root that doesn't come out to be a whole number. So what's the square root of 9?
3, so that's one of mine. Whole number.
That is one of yours, because 3 times 3 is. So square root of 9 is too boring for us. That gets back over to the rationals. However, you got a number like square root of 2, and I don't expect you to remember that. Get your calculator out and go square root of 2, and what it says, 1.412123562, and that keeps going forever. Because they go forever, part of the irrational numbers.
Wow, Ms. Wilkie, it's pretty impressive.
I thought so.
I guess they're both useful then.
They are both useful. So just give me one last time, what's a rational number again?
Whole numbers, fractions, recurring decimals, terminating decimals.
Wow, so the whole set of boring numbers that all kind of finish off, that's your rationals. So, or you can come over here to these irrationals and remember those are numbers that keep going forever and there is no pattern because they are unpredictable.
Fair enough.
Hope you've learned something about rational and irrational numbers.
You're unbelievable.